So in this example, if you see, this is a vehicle emissions actually, this LC analysis is done over here. So materials are actually extracted and sourced from the like minerals. Then it goes for the component manufacturing from the help of like a different other like manufacturers and subcontractors. Then the vehicle goes for the like it's a final assembly, and then it comes out in the market on the road. A user actually buys it, and then it goes for like a it's like a regular consumption of its like a fuel. So on the fuel, it's going to run for its entire actually working life, and that is where it starts actually consuming a lot of fuel depending upon its uses, and there will be of course the emission part of it. So that with this actually like a such a product, this regular actually energy fuel consumption and the emissions are going to be there as long as the product is in its use, and at the end of its life cycle it goes for like a recovery, extraction and recycling and disposal, etc. So actually if you see like here this the blue actually box says about the current vehicle emission regulatory focus. So the focus over here is on the improving the emission part of it. So if we actually focus on improving the emissions, like you may have actually heard of the like a different Bharat emission stages. So Bharat emission stage 1, 2, 3, 4, 5. So there are actually several stages, and these stages actually they actually lay down actually measurements. They lay down actually the maximum permissible actually limit of the emissions of like a different actually compounds which come out of this actually the combustion engine. Okay, from like a petrol and diesel, and so actually these actually recommendation actually demand improvement from the like manufacturing companies to improve upon the emission. So you may have heard like the fuel itself was actually refined like a several times to actually remove the compound of like a lead from this from the actually the petrol and hydrocarbon based actually these fuels. And secondly, the energy efficiency of the like engines were also like optimized, and then the fuel emission actually capacity was also like a kind of the threshold was actually raised high, the bar was actually raised high, and with every actually stage adoption, the efficiency actually it is expected that the efficiency will improve by a significant actually leap. So you may have actually heard from the like Bharat stage 3, the government of India actually planned to move to directly to Bharat stage actually 5. So skipping the level of 4. So that's actually a significant jump. So this information was actually laid like years ago in advance to give it to the automobile sector like a manufacturing companies, so that they can prepare accordingly in the in the time, and from the like expected year of like the implementation of Bharat Stage 5, like such vehicles were only allowed to like as a roadworthy. So this is actually a potential of actually conducting like a LCA and EIA like a analysis so that they help actually restructuring the re-engineering the entire life cycle of a problem of a product. So even if you intervene at one stage of it, that is good enough to improve upon the well, maybe at least one approach, like for example like here we are talking about like improving on the emission part of that actually automobiles, like for example like four-wheeler cars. So that is how actually the a conscious actually decision for like manufacturing of any product actually takes place. So yeah, so this is actually a schematic life cycle of a like a vehicle over here, so that we have seen in the previous slide also. So it goes for like a from the resource material to like a manufacturing, then its uses, then it's like a fuel consumption, then reusing, manufacturing, okay, recycling, then again it goes back. So this is how actually keeps on actually moving. So the exhaust, the materials, the components which cannot be actually recycled, they become actually the bottleneck in any like a such this thing. So here we will see life cycle of a like a courier companies, like a package car. How do they actually do this thing? So if you see from here from the design, so the package cars are built to last with an average lifespan of approximately like a 20 years. In India, actually, a vehicle is designed for a general like a actually a consumer actually vehicle, like a four wheelers or a personal owned vehicles. They are designed for a lifetime of 15 years. So at the time of the registration, when we go for like our vehicle registration to the registration authorities, so they actually issue this roadworthiness certificate, that RC, registration certificate, which is generally valid for like 15 years. So after 15 years period, actually the vehicle becomes like a unroadworthy. So here actually, if you see, the actually vehicle itself is designed for like a life cycle of like a 20 years, which is good enough for like a commercial vehicle, because the technology also significantly changes in a span of like a 20 years. So the amount of the materials what they have used over here, so up to 98% of the input materials are used from like a recyclable or recycled actually sources. So that's actually responsible way of manufacturing actually such vehicles, which are specifically designed to serve actually one company, one brand. So there it shows this is conscious effort. So on the fuel efficiency part, if you see, there are actually 17 configurations of package cars to right size for the optimal efficacy. So those actually configuration actually depends on the volume and the weight which this vehicle is going to carry, and the kind of a terrain and the landscape on which it's going to like operate, like whether it is a congested like a city we are talking about, or are we talking about like a countryside, or are we talking about like very heavy vehicles or the medium heavy vehicles, or maybe a lighter actually goods vehicle. So depending upon this, they have actually configured 17 actually configurations to fit in with the optimum actually engine capacity and chassis capacity. So this is how actually the company has planned to bring in efficiency in this like a automobile actually unit. Next, if you see, they use actually alternative fuel and technologies also, apart from like a depending upon the hydrocarbons based. And on the operations actually stage, that this company is well known for like optimizing its like a movement of these cars. So they always actually on the layout part, like from point one to point two, they always follow actually the path of the least resistance. That is why they actually keep on moving without actually crossing any like taking left turn. They keep on actually taking right turns. This is in the context of I think United States I'm talking about, and that is why actually minimizing the number of like red lights which may be installed in their like a path. So with the use of like a telematics, with the use of like a GPS, with the use of like a city layout, like a maps, etc., and the addresses on which the vehicle is going to deliver the goods, this is how actually they plan the movement of that traffic, and they keep on actually tracking the real time actually data of the like a traffic movement and volume on like a certain sectors, and that is how actually they drive the movement of like this vehicle. In the midlife of this vehicle, they go for actually sometimes the changing in the it's like a this like a converting it to like a electrical propulsion based actually vehicle. And so some actually changes, some actually retrofitting they carry out in the midlife of this vehicle also. On the maintenance part, if you see, they emphasize on like a preventive actually maintenance rather than going for like a corrective actually measures. So this is a very actually an efficient actually strategy once if like a number of like a fleet is concerned, because there will be n number of vehicles to be taken care of by the respective like drivers. So it is always better to go for like a preventive measures to minimize actually the breakdowns and the inefficiency in the operation stages. In the end of the life cycle stage, obviously they go for the like a approved agencies and approved like a vendors for like a responsible recycling, reusing, and dismantling and disposal of the vehicle itself. So this is actually a responsible way of going for like a vehicle design, and this company has actually shown the way. So here if you see like this actually table, this is talks about the climate change impact from like a different cars like a life cycle phases, from like a extraction to like a distribution, use, and disposal within the 95% confidence interval, according to like a this like a RECIPE recipe actually midpoint. Is an actually an analytical actually analogy on which they have actually drawn actually this graph over here. So see this vehicle, this has the actually in the highest actually this CO2 emission actually contribution, followed by this even this is a very famous actually model which came as a hybrid actually technology automobile in the some selected markets in the world. So this is also one of the actually found to be the second highest actually contributor for the CO2 this thing. Similarly, if you see over here, this is a actually LCA taken from this agency which talks about the LCA of wool. So it goes from sourcing the raw material from the a sheep on the a sheep farms. Then it goes for the a processing. It uses a certain amount of a chemical, certain amount of a energy, water, other other processing materials and agents. Then it goes for the a transportation. It is distributed to the factories where the garments and woolen cloths are actually prepared and manufactured, and from there again it goes to the a market, and then from there it goes to the a user. Then user uses it for a number of a years for it's a usable time. Then again it goes at the end of the cycle, it goes back to the a nature. So since this is a material which is primarily taking from a nature, like a wool in itself is a natural actually yarn based a material, but the chemical compounds and the treatments and the colors and these things actually add up to the actually hazardous component of this as a product. So we saw in the a previous lecture, so how the these coloring agents, how these pigments which are synthetic which are manufactured from companies in the manufacturing units, they actually cause damages to the aquatic life and ecosystems. They actually pollute the water as a unit. They actually spoil, they actually contaminate the top soil of the places where these actually processing units are actually placed. Let's move on to seeing the textile. So how the textiles actually works. If you see from starting of the a material to, and the energy inputs, okay, so it uses actually these things to extract, okay, the yarn and the fibers. Then it goes for a processing of to making them into a natural or a synthetic actually fibers. And then it goes for a dyeing and finishing procedures. Then it goes for a sewing and assembly, preparing actually final garments. Then it is sold to the customer, okay, from the markets. Okay, so there actually this transportation and other emissions are actually generated over there. Then it at the end, after the end of its a life cycle, is goes for the disposal. So from disposal, if you see, there are some of these arrows are actually going down to different other life stages. So from the first one, you see it goes for the a reusing. So for example, refurbishing the older garments, or maybe selling it as a second hand actually garment. There are some markets in the some countries which sell actually second hand used garments. And then it goes even for a remanufacturing. For example, the smaller pieces or the bigger pieces of the cloths can be turned into a smaller actually pieces of the some maybe some garment or something like that, or maybe using the components of it like buttons and zippers and things like that, because they also form a huge bulk of this textile industry. Then it goes to again again if it goes to the this processing unit, then it actually closes the cycle of its a life cycle, and it becomes like this. But if there are some open loop recycling, or if it ends up in the landfill, so that's the actually worst part which could actually happen with this industry. So this is where actually it gives a generic actually lifestyle of this textile industry. So here we will see in this one, progressing from the previous slides, strategic actually sustainability and life cycle analysis of an electric vehicle. So this is particularly taken from EU countries, and what they actually project for year 2050. So what are the actually strategic comparing and the factors what they have actually taken care of each one for the each of these components of a life cycle stage. So into they have divided into a three components, so having a this negative impact, having a slightly negative impact, and having a neutral impact. So based on that we will see. So for a life cycle phase for the extraction part, so here they have actually taken If it is being taken from the like a fossil fuel based actually sources, then it is kept in the like a negative red area. If it is taken from like a BV powered by wind generated energy, even then it is kept in the like a red area, negative area. If it is taken from like even the renewable fuels and wind energy generated electricity, even then it is taken into the negative area, because extraction in itself as a process has actually a lot of like a impact on the surrounding and the ecosystem of any place. So extraction as in principle has kept in the like a negative category only. In the production part, if you see these two are in the red, but the renewable sources, like if it is consuming energy from there, then it is taken into like a slightly negative area. So most of these areas are into red or either like a yellow, whether it is like distribution use, waste extraction, production, distribution use, waste extraction, etc. So on these ones, so the only neutral impact area what I see in the time of the like a production, if it uses like a renewable energy sources for its production. And so it has actually divided on the like a principles of like a four, like a sustainability principle 1 2 3 4, you can see over here. So this is how actually they have actually bifurcated. So I think such kind of strategies and such kind of like analysis are very important for us to not just understand the ecological impact portion of like any product, but to understand even the impacts on the like economical aspects, understanding the impacts on the like social impacts also. But majorly actually EIA and these LCA tools help for actually analyzing the environmental impacts, at least understanding the life stages, like and how the life stages of any product are going to have some sort of impacts and how we can improvise on them. So this is a very like a interesting and useful tool in like a recent times, which was like a actually prepared. So and we must actually learn it. Maybe for your own understanding, you can undertake some analysis of any like a household product which you are familiar of, and you can understand like how it behaves at the different life stages of its like a life cycle. Okay, so this actually slide talks about the paper making life cycle. So of course paper actually industry, paper and pulp industry is a highly intensive, highly like a toxic industry. Also it consumes the primary resources of this planet, which are the like trees. Okay, so it consumes most of like all of these, mostly these papers are actually made up of like a paper only. A very like small amount of actually papers these days are used as like a recyclable material, because once paper actually goes into processing, so depending upon its quality and the finishing what is given, it becomes actually a complex material again to take it back as a like a to the like a recycling unit. For example, I'm talking about like a lamination which happens on the like these papers. So this lamination actually process actually it installs actually a thin layer of actually plastic on this paper with the heat pressing method, and then at the end of like a life cycle, that actually paper becomes very difficult to take these two components out, because it uses like adhesive also. And then there are like the recovery and the kind of the value, the economic value which is this actually paper, this recovery is going to give, is lesser than what it will what it will give than what it will consume. So that is why it becomes very difficult for the industries to actually recycle like some of these materials also. And second, which is the most actually hazardous part of it, the kind of the pigments and the color which this paper industry actually uses to bring out these very shiny and nice and appealing looking actually prints on the paper. So that also exerts a lot of impact on the like ecology. So this actually slide talks about copper tube, how the copper tube. So just for an example, what is taken over here is the copper tube of like a 15 millimeter diameter with 1 wall thickness. So how they have actually used is this thing. There are actually several stages shown over here. The primary energy consumption remains at this quantity. Then there is like a global warming potential, how much it exerts in the like terms of like a CO2 emission. Then there is like a acidification potential, so how much it carries. And then it eutrophication actually potential, then there is like a ozone depletion potential, then there is like a photochemical ozone creation potential. So there are several other types of like after wave effects are also possible with these manufactured articles, which we generally do not get to know in like a generic like a public life. But most of these materials have actually catastrophic resultants, catastrophic actually results. So as we can see over here, a simple product like a copper tube can have actually these many types of like impacts, which are very crucial in the long run. So imagine the volume of such products which this world is actually producing across all the countries, and the accumulated actually impact of all of that put together. So how much it will become like. So this is actually intent of actually talking about this course over here. Well, you may be having already some idea and some knowledge about like a LCA, but with the help of like a such case studies, my intent is to make you aware of like how this LCA actually process is very important to be undertaken before actually going for like a fabrication and manufacturing of like any product, any item, or even like a manufacturing like a simple objects. Okay, what kind of impacts they are going to create and what kind of resources they are going to consume. So a basic analogy of this LCA and impact assessment can give us intervention areas which we can work it out in our the concept stage, in our like a design stage, in our like a manufacturing stage, to minimize the overall impact. So you can see over here like there could be like these many like a different stages, and we can actually use these knowledge for like our like a product development, refined product development, refined like a product improvement, strategic planning of that, even like a preparing policy, public policy policies and rules and regulations, like what sort of like a material, what sorts of like a threshold should be actually kept for controlling the pollution and the emissions, what kind of actually marketing and other communication material should be prepared, etc, etc. So there could be like n number of application of actually such applications, such like a tool such as like a LCA. So how what are those different actors, different like stakeholders for like calculating LCA of of a products. So at a different like a life cycle stages like research and development, so the producer, user, society, they actually play different roles like for the market recognition, for the research and like a design and development, for the distribution and production phase, like the stakeholders who are related with the material supply, energy production, labor, facilities, processing, packaging, transport, storage. So these are actually important nodes while calculating the entire life cycle of a product, and where we can intervene to improve the entire actually life cycle. Similarly, you can see some stakeholders and some actually features over here also, like from the operation and support we see like a warranty services, and from the retirement and disposal we see like a disassembly, reprocessing, recycling, disposal, etc. Well, these terms are repetitive, but it is very important for us to understand them in the order, in order of their like appearance, when they come and how do they come, and how we can make our intervention. So there could be like a several strategies depending upon the life cycle phases. This slide actually very important for you to note and understand. You can make note of the finer like strategies which are given on this particular slide over here. Like at the pre-production stage, we can go for like these many strategies which are like reducing the use of the raw material, choosing the plentiful raw material, okay, not the scarce material. We can go for reducing the toxic substances used in the like a product manufacturing. We can go for increasing the energy efficiency of the process itself. We can go for reducing discarding and the waste. We can go for increasing flow of the recovery and recycling. So these many things, well, there could be even more, but at least these many you can note down for the pre-production stage only, with the help of which we can improve the LCA of any product. And at the production stage, you can go for reducing the intensive use of the material, so we can minimize the use of the materials, the wear and tear, and that's how we can extend the longevity of that product. We can go for like using materials with the low impact,
The materials which, like for example, for constructing like the houses in the rural areas, it is like a traditional practice to go for like a mud constructions, using like a timber, using like a bamboo. But in the recent times, in the in the post like a globalization era, mostly the architecture in every country, almost like every city and town, it is taking the similar actually a style of the architecture which is evolving. So there is no much like a difference between like an architecture of like a one place to the like other place. But if you see like the vernacular architecture, so the vernacular architecture actually evolves at that place. It carries actually that characteristic, it carries actually those features which are very very rooted to that particular place. So those kind of actually characteristics actually being lost in this actually post industrialized era. So in the distribution also, we can actually work for planning the most energy efficient shipping methods, distribution and transportation methods. We can go for reducing the emissions of the transport. We can go for using containment system for toxic and dangerous materials, reducing like a packaging. We can go for using packaging with low environmental impact if it is at all needed. We can go for reusing the packaging material, because packaging also forms the one of the a larger bulk of the waste material which comes out of like these any like a packaged material. So the product actually goes for the consumption, for the uses for like a certain number of like a certain like a duration of time. But the packaging material gets actually thrown immediately once the product is actually delivered to the user. So the packaging itself is one sector where we can actually work for improvement. So if we just focus for the like a packaging material, and at the like a production stage of the packaging material, pinpointedly if I go back and look at this actually life stage, so we can work for reducing the intensive use of the material. We can go for using the materials with the low impact. We can go for reducing the use of the toxic materials. So we should not use actually toxic printing and inks in the on the packaging. We should not go for the very complicated actually treatment, like these days very fancy packets are available for like even like a smaller things, like a few number of like a chips and few number of like a biscuits. Okay, and immediately the once the actually the packet is bought by a customer, the packet is actually thrown away. And the packet actually goes for like a very hard life for its like a disposal and recovery, because it becomes very difficult to recycle and reuse them. So we can go for actually using materials on the basis of their like a required duration, like how much of like a life is expected out of that packaging material. So it should be designed to last only a little more than that, or maybe twice of that, not more than that, because otherwise it's going to live there somewhere in the ecosystem, and it will keep actually creating a trouble for the ecology. We can go for even selecting processes with the low impact and high energy efficiency. We can go for with the high technological efficiency. We can go for reducing discard and the waste. So we can go for even behavioral changes also. And the use stage, if you see like using products under the intended conditions only, planning and execution of servicing interventions, for example like diagnostics, maintenance, repair, etc. We can go for reducing energy consumption and emission during the use itself, because we saw in the like automobile industry it becomes very critical. And for like for a product like a chair or maybe a table, the longevity becomes actually very important, and the embodied energy becomes very important, because that once that actually unit is bought, once that furniture piece of furniture is bought by the consumer, the furniture is going to last for like a wider actually a duration of time. So the longer it serves, the better it is. So that is actually these kind of these actually approaches may differ depending upon the these criticality for each like a product or the product category. So depending upon that, we can choose the intervention area, and we can actually go for like some strategies, adopting like such strategies for the improvement. In the retirement stage, if you see like facilitating product disassembly at the end of the life. So this is what I was talking about with the context of like alloys and like other composite materials and compounds, etc. It becomes very difficult, extremely difficult, sometimes like impossible, sometimes completely not practical or economical to disassemble or decompose them or disintegrate them again into their like a different elemental and molecular forms. It becomes extremely difficult. And so we must actually choose our like products in such a way that they are not that difficult at the end of their life stage. And again, we can go for like analyzing the condition of the materials and their residual life. We can go for planning the recovery of the components at the end of the use. we can go for planning material recycling at the end of the use, we can go for reducing volume for the disposal. So there are several, smaller approaches and smaller strategies which can play a vital role in overall actually these control for the LCA. So in LCA, as we discussed in the previous slides, the things which we cannot actually measure, they cannot be managed. So this is one of the actually disadvantages in the LCA actually analysis. So we must actually code, or we must actually quantify the components and the whatever the kind of numbers which are getting associated with them, so that some analysis can be actually made. So based on this, some a qualitative life cycle assessments and some quantitative life cycle assessments are also made. So we see over here this qualitative life cycle assessment analogy is made. So there is if you see, there are no a standard access or rating system, so organizations can adopt whatever metrics work for their purpose. So it depends actually on the product, it depends on the components which you are trying to analyze, okay, and it depends on the context in which you are analyzing, like which country, which place, which city you are talking about, okay, from where you are sourcing, how far the resource actually places are, how far the distribution places are, how far it's going to get recycled and all this. So it is very contextual also in these actually values, if we see. So these are actually some qualitative traits for the analysis. So you are mostly you are free to choose and modify these standard tools. So that is why actually there are no actually standard given tools for which can fit to every product or every actually category. Let's move on to this next slide. So here also it talks about evaluation approaches become even more effective when adopted by more than one company and all. So of course there are some approaches, and if it is getting a success and a different application, different companies, different organizations, so of course the its acceptance will start increasing, and one can claim that yes, this is one of the actually acceptable formats of analyzing a life cycle analysis of any product or something. Okay, so this circle which we have been seeing for several times, so this is the actually questionable area. Okay, well in a life stage of all of these stages of a lifestyle of a product, everywhere you can find opportunities where you can intervene. So you must keep this life stages in the mind, and you keep thinking whichever area you need to improvise, whichever area you need to improve upon. So overall the products actually, the green value, the increasing the green value is the overall objective. Well, you can go for analyzing it, breaking into a several life stages, several parts, components and things, and then overall, in an overall sense, you will be able to actually draw some inferences. So as we have seen some case studies, this case study talks about supply chain of genes. So how this genes material actually as a product, as a material, it behaves in the ecosystem, how it exists in the ecosystem. So of course genes is mostly derived from a cotton. Okay, so the cotton industry, and then there are some some percentage of synthetic polymers also are used to add a flexibility and stretchability and these features. So based on actually the application, how rugged and how fanciful and how the density of that the weave, the density of the, and how many number of plies. So jeans comes in the several plies also, one layer ply, two layer ply, even triple layer ply. So depending upon actually this specification, so the costing and the complexity actually increases. Okay, so from the origin, from the sourcing, then it goes for the refining. Okay, because cotton refining also and processing is an extensive, the water extensive actually process, and then it goes for the transportation, then it goes for a dyeing and other treatments what we have seen, coloring, etc. Then it goes for a transportation to the unit where it will be prepared into the ready garments. Okay, ready a jeans units, jeans pants or whatever, and then it goes for the assembly, then finishing, then it goes to the labeling, packaging, etc. Then for with the transportation goes to the warehouse, then again it takes to transportation. So see, n number of transportations are actually involved in any actually of these a commercial value products. So this transportation sector actually this actually contributes a lot, a major factor for the like indirect emissions are actually concerned. So these indirect emissions are one of the very voluminous actually contributors for the overall actually impact of any product. And then from the retail it goes for the to the like a end user, and then from end user it goes for the like a disposal, etc. And then there is again this strategies come at the end of this life cycle, like reselling, reusing, and recycling, etc., refurbishing, etc., which we have discussed earlier. So this is how actually jeans also works. Well, jeans is a very comparatively a tougher and a stronger actually fabric garment, so usually it lasts actually longer, so it saves compared to like a other like a clothing material, it saves like a on the like a longevity part actually. Okay, for the food waste, if you see here like how the food waste actually works, we may have seen like a in like our dining halls in the like institutions, campuses, or even like restaurants, hotels, etc. There is always actually certain percentage of food which usually gets discarded. When food is a very costly material, it's not just the monetary cost of it which we pay from our pocket. Food has actually a lot of cost and on the ecology, lot of cost on the like emissions, lot of cost on the transportation, lot of cost on the energy and resources and the effort which is like a being put up. A crop of like a wheat or paddy takes at least 6 months of cycle to produce and grow, and then it reaches to the processing units, then it reaches to the our homes when we buy, then we prepare, okay, then we eat. So it's a very long and it's a very extensive and energy actually consuming process. So we must be actually responsible towards saving actually food, because on an average a huge percentage of this food actually just go waste by as a like a leftover from in our like a plates. A certain company actually you can see over here has given a conscious actually effort to minimize the actually wastage, minimize the actually the raw material or even the like a finished material from its life cycle, and they have actually tried to close the circle of their one of their products. So that is why I have kept actually this actually slide at the end of this presentation, so that you can understand like how one single actually company's effort can make actually changes, can bring actually changes to the overall actually impact. So here if you see, this is actually generic actually flow of like a this carpet material. Okay, so this is the actually normal flow, this is a generic flow like a in the like a normal actually company. So from the like a virgin material up to like a 99% it goes for like a making, then it goes for like a uses, then there are some like a cutting and wastage losses, etc. From wastage it goes for like a again at the end of its life cycle is usually it goes into the all of like such material goes in the like a mostly like a landfills. A small amount of this actually material goes for the recycling and incineration, etc. So what this company did is to come up with a closed actually loop in their like a product life cycle. So as you can see from here, after the uses, almost like a 95% of this actually a component, they take it back as the in the recycling unit. And even that of course this cutting loss also of the 5%. So from 95 to 5, this is the they are claiming actually the 100% recyclability they have achieved in their product life cycle. And at the end of it you can see if it is not getting refurbished as the same product, then they are using it as like a optional use, as a like optional material for like other sorts of like a material, as you can see over here. Okay, so there is always like a extended use of the life cycle of this product, or maybe refurbishing into or reusing into different ways. So there are we will discuss in the next lectures about these R's, several R's, like there are 3 R's, 5 R's, 7 R's. So we will discuss about these in detail in our like coming lectures. So I'll keep it here for today. So thank you all.